So when you have systems of inequalities, that's when we are not just finding where two graphs meet, we are going to be shading with these. So when we graph inequalities, you're shading either above or below the line. Remember, when you graph it, you have either a solid or a dashed line. How do you know which one it is?
Whether it's equal to or not.
If it's an equal to, it's a solid line, so both of these would be solids. If it's just a greater than or a less than, then you graph it with a dashed line. So, printed these notes for you since we have the graphs. If I'm looking at the first one, x plus y is less than or equal to 2. If I rewrite this, if I subtract over my x, then I can see this is just a line. Y equals mx plus b, my y-intercept is 2. My slope is -1, so down 1 over 1. We said it would be a solid line. So draw that as straight as you can. Hopefully yours is a little bit straighter than mine. And we also have to shade with this. How do we know where to shade? Do you remember what you did? In general, if it's a line, if you have y by itself, less than would be below the line, greater than is going to be above the line. So you might be able to look at it and tell. If not, you pick a point. You need a point not on the line, so the favorite was always kind of 0, 0, unless it fell on the line itself. So if I plug a 0, 0 in, you get 0 is less than or equal to 0 plus 2. So is 0 less than or equal to 2? Yes, that was true. So 0, 0 worked. That meant we were shading everything below this line. Now this isn't my final answer, so I would just lightly shade that in. Now we have to look at the second one. So if I solve for y, that's y is greater than or equal to a negative 2x plus 4. So that's a line y-intercept of 4, slope of negative 2. So down to over 1. Again, that would be another solid line. And we have to figure out where to shade. So since 0, 0 is not on that line, you can plug it in. So you have 0 is greater than or equal to 0 plus 4. So is 0 greater than or equal to 4? No. So 0, 0 did not work, so you have to shade the other side of the line. My final answer is the overlap in my shading. So what area is shaded by both? And it's this little section in between. So on your graph, I need to be able to tell what your final answer is. So whether that be you come back and erase all your extra shading afterwards, or you just make that part, the overlap, really dark, or some people like highlighting that little overlap. Doesn't matter to me as long as I can tell that that is your answer. So that means any ordered pair in that red region makes both equations true. You guys remember doing this? Good. Let's look at the next one. We're going to do another linear one. So the first line, x minus 2y is less than 6. So if I want to graph this, what would you do first? Subtract the x. I have to divide by -2 now. So it's dividing everything by -2. If you divide by a negative, what happens to the inequality? So negative x divided by -2 would be a positive 1/2 x. 6 divided by -2 is -3. So if it's just a line, I always recommend just getting it in y equals mx plus b. Then we can graph it easily. The y-intercept is -3. Slope is 1/2, so up 1 over 2. Solid or dashed line?
Dashed.
Dashed, because it doesn't have an equal to. Okay, can you look at this equation and tell which side of the line you're going to shade? Greater than would be above, but you could always put in a point. 0, 0 isn't on the line, so if I plug that in, I get 0 is greater than 0 minus 3, so 0 is greater than -3, and that's true. So 0, 0 works, so you shade where the 0, 0 is, so that's above. And we're just lightly shading that because it's not the final answer yet. Now we do the second one. So first step would be, okay, divide by -4, which means my inequality flips. So that's a line with a y-intercept of 0 and a slope of 1/2. Solid or dashed? Dashed. Okay, which way is this one going to shade? Down. If you couldn't tell that, plug in a point. Can I do 0, 0 this time? No, because it's on the line. So I need a different point. Anything works as long as it's not on the line. So maybe I did 0, -1. So if I plug that in to, you can do the original or what you solved for, it doesn't matter. So if I did the original, I get 0 plus 4 is greater than 0, and 4 is greater than 0. That's true. So this point works, so that does confirm we're shading down. So my overlap is the middle. Darken that in so I know it's your final answer. What if they had went opposite directions and there was no overlap? What do you say? No solution. So it does. They won't always overlap, and if they don't, it's just a no solution. Any questions there? I wanted to look at a couple that were not linear. So here is our first example. X squared plus y squared is greater than 9. Does anyone know what x squared plus y squared looks like? It wasn't one of our parent functions. So what do we do if we don't know what a graph looks like? We can't even put this in our calculator because to put it in the calculator it has to be y equals. So let's make a t-chart and graph it. If I plug in a 0 for my x, then I would have 0 plus y squared, so y squared, if I just do equals 9, what would y be? 3 or -3. So that's like 2 points. When x is 0, we could get out a +3 or a -3. If my y were a 0, then I would get x squared equals 9. So then my x could be, can you tell what this is? Yeah, it's a circle. We could do more points, but this is all we need. There's no equal to, so it's dashed. Okay. To decide where to choose shade, 0, 0 isn't on the line, so we can plug that in. So if I put that in, I get 0 plus 0 is greater than 9. So is 0 greater than 9? No. So 0, 0 does not work. So where am I shading? Outside the circle. So I've got everything except that little center part. Okay. What's the second equation? That's linear, so we could just subtract our x. So y-intercept is 3, slope is -1, so down 1 over 1. Solid or dashed? It has an equal to. Okay, now we need to figure out our shading, so you could do 0, 0. You get 0 is less than or equal to 3. True or false? True. So 0, 0 works, so you're shading below this line. So our overlap is everything below this line and outside the circle. Any questions on that? So one more nonlinear one. What's the first one, the equation of a parabola? What does the -4 do to your parabola? Shifts it down 4. So if you know what a parabola looks like and you recognize that, you could just start plugging in points, like you'd have 0, 0, move down 4, 1, 1, move down 4. If you put in a 2, you get 0. I always ask for a minimum of 3 exact points. You could also, if you need to, make your t-chart and just plug in some x values. Is that one solid or dashed? Dashed. Okay, to figure out where to shade, we could put in 0, 0. So we get 0 is greater than -4. True or false? True. So 0, 0 works, so we're shading inside this parabola. What's the second one? That's just a line. You can just graph it. Y-intercept is -2. Slope is 1, so up 1 over 1. Solid or dashed? Solid. If you need your test point, you get 0 is less than or equal to -2, which is false. So 0, 0 doesn't work. That means you have to shade below this line. So where's the overlap? This little bottom part of your parabola. So we've done linear and we've done non-linear. Any questions so far? The last thing I wanted to touch on, all of these just had 2 equations, but you could have as many as I gave you. So I wanted to look at a couple where we have more than 2 equations, and then I'm done for the day. So no matter how many equations I give you, you're just looking for the overlap with all of those. First one, x is greater than or equal to 0. If I wanted to graph x equals 0, what is that? X equals is a vertical line. X equals 0 would just be the y-axis. Solid or dashed? Solid. Okay, there's my x is 0. Greater than would take me which way? This way. If you wanted to plug in a point, you would have to do like 3, 0, and if you do 3 is greater than or equal to 0, that does work. So we're shading this way. Don't do too much scribbling on your graph quite yet because we have a lot of stuff to put on here. So I know I'm shading, basically I'm only looking at everything to the right of that. Okay, what about y is greater than 0? That's horizontal line at 0, solid or dashed? Dashed. Okay. Greater than would be above. So right now, what's my overlap? This first quadrant. That's where we're going to be looking. Okay, the next one. This is linear, so what do I do? So y-intercept of 2, slope of -1, solid or dashed?
Solid.
You might recognize greater than would be above the line, but if not, you do your test point, you get 0 is greater than or equal to 2, which is false. So 0, 0 doesn't work, so we're shading the other side. So basically we're still in the first quadrant, we just don't have, we took out that little bitty corner there. One more line. So what would we do for this one? And then, which flips my inequality. Whoops. So you get y is less than 2x minus 4. Solid or dashed? So y-intercept 4, slope of 2, so up 2 over 1. If you put in 0, 0, you get 0 is less than -4, which is false, so 0, 0 doesn't work, so we're shading this side. So the overlap, we already knew we were only in the first quadrant. And it's this little region right here. So the thing you have to be careful of, the more equations you get, kind of the uglier your picture looks. So just make sure you can tell where your shading is. Any questions on that one? example for the day. Your homework is going to have something that looks like this. We know if it's x equals a number, what kind of line is it? X equals is vertical. When I say x is bigger than -4 and smaller than 0, that means you have two vertical lines, one at -4 and one at 0, and we're shading in between them. If it were a y in the middle, then they would be two horizontal lines shading in the middle. So we have a vertical line at -4, dash because there's no equal to, vertical line at 0, also dashed, and we're just talking about everything in between those two. Then the next two should be easy. Those are just linear. So subtract your x, you get y is greater than -x plus 2. So y-intercept 2, slope -1, so down 1 over 1. Solid or dashed? Greater than means above the line, or if you plug in 0, 0, you get 0 is greater than 2, which is false. So 0, 0 doesn't work, so we're shading this way. Final one. This one has a y-intercept of 10. Slope is -2, so down 2 over 1. Again, dashed. Less than would tell you below the line, or if you plug in 0, 0, you get 0 is less than 10, which is true, so 0, 0 works. So we shade this way. So the overlap, remember we are in between these vertical lines, is just that little piece. Are we okay with this stuff? I have a handout for you.